Okay, let's start class. Okay, this is the second part of class. All right, so prime number, okay, I copy the definition here. Let's look at the definition. Maybe you already know that, right? A prime number is a positive integer that is divisible by exactly two positive integers, one and itself. Okay, and according to that definition, 2 is a prime number. That's very important. 2 is a prime number. Now, some students always think prime number must be even odd number. No, 2 is the only even number, which is a prime number by definition. And as the prime numbers must be odd numbers, the reason is if it's even, there'll be 2 times some number, right? So, so then it's not going to be prime number, okay? A composite number, roughly speaking, is a number which is not prime number, right? So it's a positive integer that is divisible by some positive integer besides the 1 and the number itself. So it's just a prime. It's a number, not a prime number, okay? Right, so 2 is a prime number. This is a very important fact, okay? If the sum of a prime number is going to be odd number, okay? So here's a good question, okay? This is a if, okay? If P and Q are prime numbers, okay? Such that P plus Q equals 49, okay? My question is, what is P plus, what is the sum of the reciprocals? Okay, this is maybe a little bit more advanced, but I just want to tell you the statement will be like that. The sum of 2 prime numbers is 49. What is the sum of their reciprocals? Okay, so that means, think about prime numbers. If both prime numbers are odd numbers, the sum must be even. So now here the sum is 49. You only have one equation. So this really implies P equals 2, and then Q must be 47. Okay, that's the only solution you can get, because 2 is a prime number. Okay, 2 is a prime number. So therefore, the sum of the reciprocal is 1/2 plus 1 over 47. You can combine them, and you get 94, and here's a 49. Okay, 49 over 94. Okay, this is sum of, and it's interesting, right? The 2 digits switch to numerator and denominator, also switch the digits. Right? So this is so be careful, 2 is a prime number. Don't forget that. Two is a prime number. And so here's our question. Okay, the product of all prime numbers between 1 and 80 is divisible by 10. What is divided by 10. What is the remainder? All right, first of all, I know you got 0. Someone get it. All right, sometimes maybe this is just a very tricky problem, very few people can really multiply them out to get all the prime numbers, right? Prime numbers, you can write down 2, 5, 7, 8, 9, 11, 13, right? 14, 16, 17, that's 19, right? And 23, and maybe you can quickly get to some number close to 80. Maybe I change 80 to 1,000, 1 million, right? So, so that choose the number 80. Just make sure it's not too big. So some students probably are tempted to write down all the prime numbers. But again, the same reason. 2 is a prime number. 5 is a prime number. Okay. 2 and 5 multiply them out, you get you will get something here, and you get 0. So 0 shows up the last, the unit digit is going to be 0. If the unit digit is 0, then you can, then when divided by, it's divisible. So it's divisible by 10. If you divide by 10, so the remainder is going to be 0, right? Remainder is going to be 0. I have another question similar to that. Okay, I want to ask you how many zeros you're going to have. Okay, so question: how many zeros are at the end of the following number? This number we have a notation called 64 factorial, which is going to be 1 times 2 times 3 times 4 times 5, all the way to 64. Okay, can you do this? So if you multiply them out, how many zeros you're going to get? Okay, this is nothing to do primes, but we use some ideas for the previous problem, from the previous problem. So Elaine says it's 13. Okay, so possibly it's 13. Okay, let's look at why how do we get 0? Only when 2 times 5 0. So you all have to do is make sure that how many 5 there. How many 5 there? You have 5, 10, 15, 20, right? 25, 30, 35, 40, right? 45, 50, 55, 60, right? And then you have to be very careful about 25 and the 50. There's a double 5 there. Okay, so you have to double, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14, right? I think it's 14. So there are 14 factors 5 there. So the answer is there are 14 zeros, okay? And if you just have a factor of 5 is not enough. You should have a plenty of 2s there. There are lots of 2s there. Between any 2 5s, there are plenty of 2s there, okay? There are, there are many 2s there, like between 25 and 35. You have lots of even numbers there. Every even number contains a factor 2. So 2 more than 14 2s there. So you have 14 5 there, and then more than 14 2s there. So each 2 and 5 they're multiplied out, you get 10. So that's why it's guaranteed. All you need to do is just check how many factors 5 there. Okay. All right, so let's take a look at the prime numbers again. Now this is difficult. Okay, the product of all prime numbers. Should you know all the prime numbers? Okay, right. So should you know all the prime numbers? Because if you really want to do that way, it cannot be solved. Okay, you have you have so many prime numbers between 1 and 80, right? Prime numbers. Okay, there's just so many prime numbers there. Yeah, so the 80 is the last one is 79. Okay, let me write down all the prime numbers. And now it's going to be 2, 3, 5, 7, 11, 13, 17, 19, I think the 23, and the 29, and the 31, maybe I missed 37, 41, and 43, 47, 53, 59, 61, 67, 71, 73, and 79. Okay, but if you want to multiply them out, we already discuss, right? It's not easy to figure out, right? The remainder. Okay, so let's take a look at what kind of, first of all, okay, are the numbers, okay, first of all, let's see. And other number is divided by 4. Okay, what you can get? Other number. Okay, all the numbers, let me explain this way. All the numbers can be written in the form like this. All the numbers can be written in the form as a multiple of 4, let's call it 4k, then plus 1, then plus 2, then plus 3, right? Then you get another multiple of 4. Then you have a k plus 1. So those are the multiple of 4. And between them, you have 3 numbers which are not multiple of 4, right? Right? But if you divide by 4, you get a remainder 1, 2, 3, right? So this is an odd number. This is an odd number, okay? This is an even. So for an even number, the multiple, okay, for an even number, right? Any even number. Yeah, let me, my spelling is wrong. Yeah, let me erase this. Okay, look at the even number. If an even number divided by 4, what kind of remainder you're going to get? If an even number is divided by 4, right? What are the possible remainders? Even number, you look at my pattern here, right? Even number, right? The remainder is either 0 or 2. So your answer is either 0 or 2, right? Either 0 or 2. So you only have 2 possible answers, 0 or 2, because when it's divided by 4, right? And do you think when it's the 0? If the remainder is 0, this number must be divisible by 4. But here the number is not divisible by 4, okay, clearly. The product of those prime numbers is not divisible by 4, clear. Why? Because it's possible it's an even number, but it's never, it does not have another factor of 2 there. So the product is not divisible by 4, okay? So why? You have to think about this number cannot be divided by 4. The reason is, yes, it's divided by 2, but there's no other factor of 2 there. All prime numbers, rest of them. So it doesn't matter if I change 80 to any number, okay? I can replace to any number. The result will be the same. Any number greater than 2, okay? Any number greater than that's fine. 80, 100, 1 million doesn't matter, right? So the product of those numbers is not divided by 4. If it's not divided by 4, then the first case it does not occur, right? So the answer will be the answer is 2. So the remainder is going to be 2 here, okay? Because it's not divisible by 4. Okay. Our next problem, I want to talk about this is too small. I'm going to change the font. Okay. So what does that mean? We're going to actually this is a we're given 2 primes. Well, I want to talk about the combination of 2 primes to see what kind of numbers I can create. Okay, and I'm going to move this. Yeah, I have too much space. I need to move down these numbers. Okay, and more space. It says that the greatest impossible number expressed by this is going to be pq minus p minus q. Now let me look at the case when p is 3 and q equals 5. Okay, I want to see what kind of combination, what kind of numbers you're going to get using those 2 prime numbers. Okay, and here n could be 0, 1, 2. M is also could be 0, 1, 2, and combined. You will be surprised. After some number, you can always express it in this form, any number, okay? So let me check. It says the greatest impossible number expressed by this is be PQ. So P times Q minus P minus Q is going to be 3 times 5 minus 3 minus 5, which is going to be 7, I think, right? Yeah, 7. So 7 cannot be expressed in this form, no matter how do you choose, okay? And because mn must be positive integers, okay? 7 cannot. And then this is the greatest impossible number expressed by this form. So 7 cannot be 3n plus 5n, okay? Now, how about 8? 8 can be done, 3 times 1 plus 5 times 1, great, right? And how about 9? 9 is a 3 times 3 plus 5 times 0, right? Great. Yeah, that's surprise, right? 10. 10 is 3 times 0 plus 5 times 2. You see, you can easily use, and then 11. 11 is a trouble, right? Right, 11, right? 11 is 3 times 2 plus 5 times 1. You see? Yeah, 12 doesn't matter. You can, any number after 7, you can express as combination of in this form. NP plus MQ, Mn are non-negative integers. Okay. Yeah, right. You can do that. Okay. Sometimes the expression is unique. Once you get this, sometimes you want to figure out. You want to find out NM. That's uniquely expressed. So let's look at 12. 12. How do you do 12? Yeah, 3 times 4 plus 5 times 0, right? And 13. 13. Yeah, 13. Can you do that 13? Use a 3 times some integers, right? Can you figure it out?
Okay. 3 times
Yeah. 3 times 1 plus 5 times 2, right?
Yeah.
Good. Right. So anyway, I just try to tell you, after 7, you can always express, but it's harder to prove. It's harder to prove. Okay. What I want to do is the following problem. It's not exactly the same problem, but it's related. Okay, it's related. I'm going to enlarge. Hold on. Yeah, we suppose PQ are prime number. We don't know the prime number. The prime number is not given. Okay, and we want to find the P and the Q. So this is a yeah. Look at this problem first. Okay. So we already, of course, 5 and 7 are also prime number, but we assume PQ are prime number. Okay. And we were trying to find the P and the Q. Okay. So first of all, the prime number, okay, and add them together. Okay, look at this, right? So 109 is an odd number. Okay, the sum, you see, odd must be even plus odd equals odd, right? Even plus even is even. Odd plus odd is even. Right? So that implies 5p is even or 7q is even, right? So just step by step, then yeah, just step by step. Okay. So which one is possible? Let's say if 5p is even, right? So what is p? P is a prime number, p must be 2. No choice. See, remember, the p is a special number. All right. Then in this case, 5 times 2 plus 7q equals 109. I can solve for q. Okay, I can solve for q. So what is the q? 7q equals 109 minus 10. I get 99, and I don't think it's impossible, no solution, because 99 is I don't think it's divisible by 99 is not going to be divisible by 7. No solution. Okay. Okay.
I think 90. Instead, you could just say that 99 over 7.
What?
If we're like if we don't have to have, if we could use
Yeah, no, we can switch it. We can say 7q is even. Okay. When 7, just use the case, right? 7q is even, 7 must be, a q must be 2. Then you have a 5p plus 7 times 2 equals 109. Then you solve for, so 5p equals, 109 minus 14. So it's going to be 95. Then 95, p divided by 95 is going to be 95 divided by 5. P is going to be 1. I think it's 9, okay? So you get solutions, okay? Your solution here is going to be 5 times 19 plus 7 times 2 is 109. Okay. That's a unique solution you can get. All right, that's a unique solution. Okay. But the property we're using here is even plus odd is going to be odd. Okay. Then also we know that 2 is the only even prime number. Okay. Right, so now let's look at the last one. Maybe it's also easy. I want to talk about related problems. Here, this is a 6 consecutive odd and positive integers. Okay, any 6, the product of 6, yeah, 6 positive integers. Okay, so to understand this, I'm going to write down positive integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and keep it going, right? I find out between 0 and 10, there was 6 consecutive integers, right? And 14, 15, it's also like this. Okay, so also have 6 consecutive digits there, integers there, 10 to 11. But we don't know what group of the 6 consecutive integers, but it doesn't matter when you move, right? When you move from here to here, okay, and there is right, so there's a 10 here, right? Right, so then from 7 to anyway, it contains either 5 or 10, or not 10, number with a 0. Okay, so what I want to say that okay, what I want to say that any set of 6 consecutive positive integers contains an integer
I think like it's even a 0 and
yeah, contains the integer ending with a 0 or integer ending with a 5. Okay, so
yeah,
either way, when you move this this arrow symbol, you always either cover 5 or cover 10. Okay, but don't worry. Okay, if it's contain, if already contains 0, then the product is always has a 0 at the end. Okay, but if it contain 5, you still get a 0 at the end. Okay, so case 1 is containing this number. Then the product of 6 numbers, right? And this 1, 2, 3, 4, and then the last number is a 0. When you multiply them out, you will get a number with the last digit will be 0. It's obvious. Okay. Case 2, you get a number with a unit digit 5. Don't worry, because when you find the product of those numbers, because this is a sequence of 6 digits, consecutive digits, one of them, the one next to 5, next to them must be even number. So there's somewhere here must be even, right? If it's even, then the product of those 2 numbers will give you 0 at the end again. So no matter which case, you always end up with a number with a unit digit equal to 0. Okay, with units digit equal to 0. Okay. So the answer is, to that particular problem, what is the units digit? The answer is 0. Okay, it has a 0. So you divide them into two cases. Okay, so let me ask you a question. Okay, let me ask you a question. The product of three consecutive integer. Okay. We want to see the product of three consecutive integer is divisible by 6. Why? You know why? It's divisible by
I just said we could just do 1, 2, and 3. 2 and 3 make 6, whatever. So just like the last time, we already know that one of it has to be an even number out of the 3, and then I mean it's either 1 or 2, but it's not 0 or 3. But it has to be exactly one of the numbers are divisible by 3. And
yeah,
2 times 3 is 6.
2 times 3 is 6. So there's a factor of 3 there.
Like even though it's like even though they're not 2 or 3, it's divisible by 2 or 3, and we could just divide them both out, and then we could just put the numbers onto the side, and then 2 times 3 is 6. And you could just look back up.
Yeah, let's randomly pick up. First of all, let's make simple observation, okay? We randomly pick up as a 3. And there's a factor of 3 there. And then at least one of them is even, right? So 2 times 3 is going to be 6. If I choose this 2, you see there's 9 here. 9 is divided by 3. 8 and 10, you have 2 even numbers. And then you still have a 2 times 3, which is 6. Okay? So it doesn't matter where you take 3 consecutive integers. One of them must be divisible by 3. Okay? One of them must be divisible by 3 if you take 3 consecutive integers. One of them must be even. Okay, that's 2 conditions. Yeah, so that means the product, okay, is divisible by 2 and 3. Okay, therefore it's divisible by 6. Why divisible by 3? Because one of them must be multiple 3. Okay, one of them must be multiple 3. Okay, if you have 4 consecutive integers, right? One of them must be divided by 4, right? Do you agree? Yes. Okay. So can you get a general theorem? You know, being a mathematician, you have to get a general theorem after you make such observation. You write down the statement. Okay, from this example. Okay, what you can say?
I would say
after you make such observation, right? Make some examples, then you get a conclusion. You know, and here you see, and let's look at that. The product of 4 consecutive integers, okay, is divisible by 4. Now, can you state that? And why? And actually divided by 3 also, because it's already contained, right? So it must be divided by 12. right? And then you can add the 3 because it's anyway, it's it's a 4 consecutive integers. So of course it contains 3 consecutive integers.
I think 4 and 12, it doesn't mean that it could be it. Because let's just get an example for two odd numbers and an even number. Usually that works best, like 5, 6, and 7. It has,
Right.
if there are two odd numbers and there's one even number and the even number is
No, I think one of them must be a multiple 4. That's any 4 consecutive integers. One of them must be multiple 4. Okay, doesn't matter where you choose. Okay, so when
if it's not a multiple of 4, they can't be a multiple of 12. If it is a multiple of 12, it could be a multiple of 4 because 12 is a multiple of 4.
okay, so one of them must be a multiple. Must be a multiple of 4. Okay, among the 4 consecutive integers, one of them must be multiple 4. Of course, it's divisible by 4. Okay, so let's look at this. A number can be, then you can generalize it. Okay, you can generalize it. So let's take a look at this. Okay, let's take a look at randomly. I pick up 12. Okay, 13, 14, 15. Okay, so there is a one multiple 4 here. That is number. Okay, if I begin with a 13, 14, 15, 16, then this is a multiple of 4. Okay, then I begin 14, 15, 16, 17. This will be multiple of 4. Then I have 15, 16, 17, 18, and still this one is a multiple of 4. Okay, okay. And then definitely there is a one number. Does it contain factor of 3? At least one of them contains factor of 3. So I can also circle this, this is this, and multiple of 3, multiple of 3, multiple of 3, but not necessarily multiple of 5, okay? Although it's always have a 5 there, you have to have 5 consecutive integers, okay? So what do you conclude? It's the product of a 4 consecutive integers is divisible by 12, okay? Because 3 times 4, okay? Okay, so you conclude in general, I will have to say that in general, here's a statement, okay? Let's prove a theorem, we never see that in the book, okay? Okay, so the theorem says that the product of any consecutive integers, okay, is divisible by k. Now, you can make it a more strong conclusion, maybe then also divisible by k minus 1, then also divisible by k minus 2, okay? So just like what they did here, divisible by 4 and divisible by 2, okay? So, but at least because one of the fact contains one of the number here, okay, is divisible by k. That's the reason, okay? Okay, so you have sometimes they ask you to, like a 5, okay? Like 5 consecutive integers, or we go back to 6 consecutive integers. This is a problem, right? We have 6 consecutive integers. What you can get? What is the number? Okay, among all the products of six consecutive integers, the product of 6 consecutive integers, what is a common factor? Okay. Okay. For the 6, let's take a look at it. Okay, this is our last problem. Okay, consider the product of 6 consecutive integers. Okay, what they can do. Okay, let's list all of them here. One of the fact, okay, one of the integer is divisible by 6, right? They agree, right? Okay. One of the integer divisible by 5. Okay, and the same, because 6 consecutive integers contains 5 consecutive integers. So, and keep it going, right? So now you can get even more generous. You know, let's look at doing research, you know. So this, at the very beginning, you did not even see that, right? So then you get, and the third, right? One of them is divisible by 4, right? So keep it going, and finally, what you can conclude is the product conclusion, right? The product is divisible by 6, 5, 4, 3, 2, and 1. Okay, 2. Okay, hi. And you can say 1. Okay, so product of 6 consecutive integers is going to be divisible by so many numbers. Okay, and that's the whole point. And among them, this is a 2 times 3, right? And this is a 2 times 2. So then it's equivalent to saying that it is divisible by, I think it's a 4 times 3 times 5, okay? Which is going to be 60. Okay, so it's divisible by 60. Okay, it's divisible by 60. Not divided by 60. Okay, so the product of 6 consecutive integers will be divided by 60. Okay, yeah, that's the product. Okay, so you can generalize the theorem. Okay, so you can say that the product of k consecutive integers is divisible by 1 times 2 times 3 times, you know, 1 divided by 2 divided by 3 divided by 4 all the way to k. Okay. So you can always, yeah, when you give a problem, you solve it. You should sit there think about how about the other cases, like how to check a number is divisible by 9, divisible by 5. Then you look at all the integer digits between 2 and 10. You find out home. How about 6? How about 7? Right? How to check a number divided by 6? 6 is 2 times 3.
I check another. It's like even, and 3 is the sum of the digits. 4 is the last 2 digits. 5 is 5 and blah blah.
That's right, but 7 is more complicated. Okay, 13 is also more complicated. So those are the problems, you know. And you can search on internet. Sometimes the explanation is not clear. Then you also try to you try to figure out how to check. That's great if you tell your parents, hey, I figured out without reading the book. I figured out how to check whether it's divisible by 7. That's a great discovery, right? Right. So in the future, you know, when you become engineer or scientist, you know, you got problems, and you should ask yourself, hey, you know, what else I can do, okay? And sometimes based on the observation, can you summarize, get a general conclusion, okay? Don't just, okay, I finish this problem, then without thinking, without go further. And you can always ask yourself, hey, what I can inspire from this, or based on the observation, what I can conclude, right? Not just look at this special example, okay? So let's stop here today, okay? Have fun. Okay, I'm in Indiana. We are 6:30 here, p.m. It's time for dinner.
Wow.
Bye-bye.
Bye. Thanks.
you. Bye bye.
Thank you.